There it is. All right, guys. We stopped here yesterday with finding the value of the 6 trigonometric functions. Now, we did list them out a little bit yesterday. Sine of a given angle is our y. Cosine is corresponding to x on the unit circle. Tangent is y over x. Cosecant is going to be 1 over y. Secant, 1 over x. And cotangent of an angle is x over y. Okay. Now, so far, we've only done one problem of these with it. So what we're going to look at next is B. 5 pi over 4. So with our 5 pi over 4, we're trying to find sine, cosine, tangent, secant, and cosecant given that angle. I did. I'm going to need to clean the screen before we move on. Make sure none of them come in. Okay, so on your unit circle, are you able to find 5 pi over 4 on there? Negative square root 2 over 2, and I think so, because that's down in the fourth or third quadrant. So we have the point negative square root 2 over 2, comma negative square root 2 over 2 for our 5 pi over 4. Yes? Now this point is denoted, we're used to it being x, comma. So the x value, the corresponding x, is negative square root 2 over 2. Y is also negative square root 2 over 2. So let's see what it says for sine. Well, sine of a given angle is equal to y, the corresponding y. In this case, it is negative square root 2 over 2. That's it. Questions on this here? Let's look at cosine. Cosine of 5 pi over 4. Cosine is equal to the corresponding x. Here it is. Also negative square root 2 over 2. So we're really just looking at that ordered pair. Questions on sine or cosine? Let's look at tangent. Tangent of 5 pi over 4 is y over x. Well, the y value is square root 2 over 2. The x value is also square root 2 over 2. And we will need to simplify. Questions on how we got to this point so far? Now, what is negative square root 2 over 2 divided by negative square root 2 over 2? 1. Anything divided by itself is 1. Now we'll look at cosecant, CSC. Well, our cosecant is 1 over y. So we'd have 1 on top. And the y value is negative square root 2 over 2. Now at this point, we do need to simplify. So we can do it by hand, or we can let the calculator. 1 over fraction, negative square root of 2 over 2 is negative square root of 2. So our CSC, this cosecant, is negative square root of 2. Any questions on any of these so far? Secant is 1 over x, which is going to be 1 over negative square root 2 over 2. Well, just like cosecant, that's still going to work out to be negative square root of 2. And the last one is cotangent. This time it's x, negative square root 2 over 2 over y, which also works out to be 1. Questions on how we got these 6 values? Does this make a little more sense? And that's part of the nice thing with the unit circle is because if we know these values, we can easily look them up instead of having to type them in each time. Did y'all get those down before we look at the next one? Next one is pi. So we're looking at sine of pi, cosine of pi. Well, pi is the point negative 1, 0. So for our y value, y is 0. So sine of pi is 0. Cosine of pi. Cosine would equal the x value, so cosine of pi is what? Negative 1. Tangent of pi. Tangent is going to be y over x. So that would be 0 over negative 1, which is 0. We do have these 3 here. I'm going to look at secant first. Secant is 1 over x. So that would be 1 over negative 1, which is negative 1. And it is possible for these to come out to be the same answer. Now let's look at cosecant. Well, this is going to be 1 over our y value. Well, what's the y value?
0.
What is 1 over 0? What are we dividing by? Remember, we can't divide by 0. So cosecant is undefined at pi. Well, let's see what that means for tangent. It's going to be, or cotangent is going to be x over y, which is also undefined. Because if one of these trigonometric functions, sine, cosine, or tangent is 0, its reciprocal, secant, cosecant, and cotangent, will be undefined. Questions on these here? Now the last one we have is negative pi over 3, yes? Okay. Okay, it is already in radians. Sine, negative pi over 3. Cosine, negative pi over 3. Wait a minute, does that also mean I could have taken sine of pi? Cosine of pi? Tangent of pi? Yeah, calculator can do all these. So for our last one, sine of negative pi over 3, I believe is what it was. Bless you, negative square root 3 over 2. flashing, or negative pi over 3, is negative square root 3 over 2. Cosine of negative pi over 3 is 1/2. Excuse me. Tangent negative pi over 3 is negative square root of 3. Questions on how we did this with the calculator? So we can do it with the calculator or the unit circle. Either one works. Unfortunately, the graphing calculator doesn't like these as much as the 30XS. And part of that is because of the square root of 3, the square roots. The graphing calculator will do it, it's just going to turn it into a decimal, and it'll leave it as a decimal. Which is fine if you know what the decimal approximation of negative square root of 3 over 2 is, but there's no reason to memorize that. Now the question is there a cosecant, secant, or cotangent button on the calculator? Let me look. We have trig inverse, but we don't have secant, cosecant, cotangent. We get angles. Nope. That's probability. So the 30x does not have it. I don't think. No. Most do not have it on there. Yep. But let's look back at the function. I think this is in the notes later on. Okay. Now we said sine of a given angle is equal to y, yes? CSC of that same angle is equal to 1 over y. Well, doesn't that just mean that sine, or cosecant here, we said that sine is equal to y, yes? I can replace that y with sine. So our cosecant is equal to 1 over sine. By that same logic, cosine of theta is equal to x. Secant of theta is equal to 1 over x. So therefore, secant of theta is equal to 1 over cosine. And cotangent of theta is equal to 1 over tangent. They're reciprocal functions. Okay, so now the question is, why is that handy to know? Let's look at secant first, because secant's nice. Secant's 1 over cosine, yes? So what are we doing with cosine? We are flipping it. What's cosine's value? For this last one. Cosine's value here is 1/2, yes? Flip it. What do we get when we flip 1/2? We 2 over 1, or just. So secant of negative pi over 3 is 2. Cosecant CSC is 1 over sine, so we would be flipping Sine's value. Sine is square root 3 over 2. So cosecant would be negative 2 over the square root of 3. You can't leave it like that because we cannot have a radical in the bottom of a fraction. And the 30xs will simplify it to 2 square root of 3 over 3. And how would we flip tangent? Tangent would be, or cotangent would be 1, negative 1 over square root of 3, which would be negative square root 3 over 3. Questions on this here? So we do have 6 trigonometric functions. But really, how many values do I actually have to find? 3. Because if I have sine, cosine, tangent, I know secant, cosecant, cotangent. Because if I know those 3, they're just the flip. Now, one thing that is easy to do is to switch the connection between secant and cosecant. Because for me, I don't know about y'all, it really feels like CSC should go with cosine. And SEC should go with sine. I just remind myself it's the other way around. SEC is going with CSC, and COS is going with SEC. We have that flip. But that's really it with these here. Questions on this here? The domain of sine and cosine is the set of all real numbers to determine the range of these two functions. All it's saying is that no matter what angle we pick, the range of values that we can have for sine are going to be between negative 1 and 1. No matter what angle we have, it's going to be between negative 1 and 1. So by definition, sine of t and cosine of t, because of x comma y is on the unit circle, you know that y is going to be between negative 1 and 1. X is going to be between negative 1 and 1. The input and so the output of sine and cosine have to be between negative 1 and 1. If we ever get a sine or cosine value where sine is equal to a number bigger than 1 or less than negative 1, it's not going to work. We cannot have a value that will work for those. Because our sine and cosine will always be between. So sine of any angle will never be greater than 1. That should always be less than 1. And sine of theta has to be greater than negative 1. It's always going to be between those two values. The only way that it'll get bigger is if we said 2 sine. Yeah, so really this is just one statement. We could just, and negative 1 is less than cosine of theta is less than 1. They're always going to be trapped between those two spots. So this is more of a side note than anything else, because if we had an equation that said sine of theta is equal to negative 2, this isn't true. There's no value for it, because sine cannot equal a value greater than 1 or less than negative 1. The only way we could have this is if we were saying 2 sine of theta, because we would divide by 2, and it's really saying that it's equal to negative 1. And the other nice thing, so this is what it's showing, is that no matter what the angle is, no matter how big or how small, 30, so these are all the 45s. Any 45 degree, any of their coterminal angles will all correspond to one of these 4. The same thing is true with our 30, 60, 90. Any of those can go across all of them. They're going to correspond to one of those 4. Well, 0, 30, 60, 90, 0, 30, 45, 60, 90. One of those 5. It's going to be represented there. Domain and period of sine and cosine. The values of t plus 2 pi and cosine of t plus 2 pi correspond to those of sine of t and cosine of t. Similar results can be obtained by repeated revolutions, positive or negative on the unit circle. This leads to this here for any real number. So all they're saying is that, let's clear this out. Let's say sine of pi over 3. Okay? Is square root 3 over 2. You're kind of good with that there. Yes? Well, sine of pi over 3 plus 2 pi is still this here. I didn't know if someone knocked or was hitting the desk. So we add 2 pi to it. So our pi over 3 plus 2 pi pi over 3 plus 2 pi. So what we had, sine of pi over 3 and sine of 7 pi over 3, give us the same answer. Because all we did, add 2 pi, we go all the way around in a circle, yes? Well, that also means, well, if I add 2 pi again, 13 pi over 3. So sine of 13 pi over 3 is still square root 3 over 2. No matter how many times we go around the circle back to that same spot, we'll get the same value sine, cosine, tangent. That's one of the reasons that the unit circle is nice, is no matter how big or small these are, all the coterminal angles will have the same value. So do y'all see how the unit circle is nice? Yes? Okay. Have any of y'all heard of something called, well, we'll get to there in a second. So this kind of makes sense why this works, yes? Now, we call sine and cosine periodic functions because it has a repetition. Functions that behave in a repetitive manner or cyclic manner are called periodic because there's a certain amount of time that they repeat themselves. And for sine and cosine, that period is 2 pi. Every 2 pi, the sine and cosine functions will repeat the values that they have. A periodic function, a function f is periodic when there exists a positive real number c such that f of t plus c is equal to f of t for all. Whenever we have those, and we can add them and get that there. So we keep getting the same value like we were seeing with sine and cosine. Odd and even. The cosine and secant functions are even because cosine of a negative angle is equal to cosine of the positive version of that angle. So what we're saying is cosine of negative pi is the same as cosine of pi. They will give us the same value. Sine, tangent, secant, or cosecant and tangent are odd. Sine of a negative angle is equal to the negative sine of that angle. Questions on this here? Okay. With sine and cosine, what they're wanting and explaining with this here is because 13 pi over 6 is bigger than 2 pi. 13, not that one, pi over 6. If I take 2 pi away from it, we get pi over 6. So sine, cosine, tangent, cotangent, secant, cosecant of 13 pi over 6 will have the same value as pi over 6. So on the unit circle, if we look at pi over 6, we would have pi over 6 is our 30 degrees. We would have the point square root 3 over 2, comma, 1/2, yes? So cosine, the x value, cosine of pi over 6 would be square root 3 over 2. Sine of pi over 6 is 1/2. The calculator, as long as it's in radians, cosine sine of 13 pi over 6 is 1/2. Cosine 13 pi over 6. The square root 3 over 2. Sine of pi over 6 is 1/2. Cosine of pi over 6. The square root 3 over 2. We get the same value. Does that make sense? And these are just different properties of how these work. Now, for the most part for us, knowing and working with these doesn't make a whole lot of sense because the calculator can do it just as easily as we can with these here. Because at one point, we didn't have a nice calculator that can do this, so we needed ways to calculate these angles quicker and faster. Because the only way that you used to be able to calculate sine, cosine, tangent, secant, cosecant, cotangent is with the table. You had an actual table, and it only went to, say, 90 degrees. You had to actually find ways to get it back on that range so that you can actually find its value. So we had to use these. Seven pi over 2. Negative 7 pi over 2. Since it's a negative angle, we can add 2 pi to get it back being positive. Well, that didn't work because it's too small. We added again. So pi over 2. So we could find sine of pi over 2. And sine of pi over 2 is, so straight up, so it should be 1. Cosine of pi over 2 would be 0. But again, the calculator, especially the L one, can do these. You just need to make sure it's in radians, RAD, not degrees. Questions on this here? When evaluating, we can use the x to the negative 1, or we can do 1 over sine to calculate those in the calculator. But that's it. Questions on this here? All right. I don't know if you've seen it, because it does pop up, I've heard, because Miss McClendon's brought it up, something with trigonometry and angles called left-hand rule. I don't know if you've heard of this here. So I'm going to try to draw a hand. 3, 4. There we go. Left-hand rule. Now the left-hand rule states this here. So 0, 30, 45, 60, 90 degrees. Because these are the main 5 that we have. Because if you notice on the unit circle, they really repeat after that. Yes? Okay. Now, 0 degrees. If we're finding 0 degrees, what you do is you take your left hand and you bring that finger in. Okay? So that leaves us with 4 above the finger and 0 below. The numbers above and those there count for cosine. The ones below are sine. Okay? So you take the number of fingers, so square root of the number of fingers that are up, and put it over 2. Okay? So for our first one, we have 4 fingers up for cosine, yes? So what's the square root of 4? 2 over 2 would be? So if we look at the unit circle, the value for cosine at that would be 1, yes? The number of fingers below the pinky that we have is, square root of 0 is still 0 over 2 is, so cosine is, or sine is 0, cosine is 1. If we look at 30 degrees, we have 3 fingers above that, yes? So it'd be square root of 3, that doesn't reduce, over 2. Cosine's value at 30 degrees is the square root of 3 over 2. Below is, what's the square root of 1? Over 2, which is 1/2, which we have, yes? Our middle finger is the 45. We have 2 above, 2 below. So they'd be square root of 2 over 2, square root of 2 over 2. Our pointer finger, if we bring it in for 60, we have 1 up. Square root of 1 is 1, so we have 1/2 for cosine. Sine would be square root of 3 over 2. 90, we have none for cosine, so that's 0. Sine, we have 4. Square root of 4 is 2. 2 over 2 is 1. You kind of see how that works? So that is the left-hand rule. The only thing you have to keep track of is the quadrant that you have. Because if we're over on the other side, we just have to switch sine and cosine signs. But that is the left-hand rule with it. But that's it. That's all we're doing today.